Hi, science students. Thank you for watching my screencast. In this video, I'd like to show you some information on how to balance chemical equations. Very brief introduction. Three questions I'm going to address in this video. One is, what is a chemical equation? Secondly, I'm going to talk about why they need to be balanced. And third, we're going to talk about how you go about balancing them using very simple math concepts and math functions. So if I said the word to you, equation, I'm sure the first thing that would come to mind would be something like this, some sort of math function, right? Here we have 2x plus x equals 3x, a very standard math equation. For chemists, the setup is very, very similar. The only difference is the terminology, the lingo. All of the information that's on the left side of a chemical equation is referred to as the reactant side. I've used that word before, but now we're kind of using it in an official manner. So the reactants are the stuff on the left side. The right side, the equals, would be the product. And instead of saying equals in chemistry, you use the term yields. And you see that little fancy arrow there. So this is a familiar reaction that we've seen in class before. Zinc reacting with hydrochloric acid to form some products. And you remember that hydrogen gas was produced and it was very flammable. We lit the top of the test tube on fire for a little bit. I want to see how observant you are. I'm going to tell you right now, there's something wrong with the way this equation is standing right now. There's an issue with this equation that we're going to address in a little while. So, question 2, why do you balance a chemical equation? And the short answer to that question is that's how nature works. If you were in school on Friday, I told you about a breakfast I have sometimes, which is a delicious pineapple and kale smoothie. If you measured the mass of the pineapple, the water, and the kale, the reactants or the ingredients, and you put them in the blender and you cut them all up, made a nice smoothie, what would be the mass of the products? Of course, it would be 38 grams. You haven't added any new materials, you haven't taken anything away, you've just kind of mixed these substances up to form a heterogeneous mixture, right? So the same is true for chemical reactions. In class, we were burning a candle and talking about how the mass would compare before and after the reaction. If I thought about a reaction between a toothpick that were lit on fire, and that reaction would react with the oxygen in the air, you would produce new things like smoke and water vapor and ash. But how would the mass balance out? Would it balance out? And of course, the answer is yes, it would. The atoms are still there in the same quantities, the same amount of grams. They're just in different forms. You have ash, you have smoke, you have some water vapor, and the total mass of all those materials would be the same as the mass of your reactants. And the father of modern chemistry, Antoine Lavoisier, would look at these two examples and he would say, of course, you are demonstrating the law of conservation. And he was the first guy to come up with that term and that concept. And he said the law of conservation means matter can't be created or destroyed. So you'll have the same amount of grams before and after any kind of chemical reaction. So that brings us to question 3, our final question. How do you balance a chemical equation? Here's a sample of one that we've looked at a few different times. If you had silvery sodium metal and it formed a reaction with toxic chlorine gas, that would yield table salt. It would form a compound with different properties. The first step to balancing this chemical equation would be to count the atoms on both sides. I use this graphic organizer and I will provide this for you on any kind of test or quiz, and I'll encourage you to use it. This table gives me some room to write down and count the atoms on both sides. So let me try doing that. If I look at the reactant side and I look to my sodium atom, there are no subscripts here. That means that I have 1 sodium on my reactant side. If I look on the product side, there are no subscripts. I also have 1 sodium on the product. We are balanced right now. These two sides equal each other. Let's look at the chlorine side. This chlorine has a subscript of 2. So I have 2 chlorine atoms on the reactant side. What about the product side? There is only 1. This is not a balanced equation. And if I were to use some help from this gizmo right here, this provides a nice visual. You have 1 sodium atom, but the chlorines do not match up. So we need to do some work. We need to go about taking some steps to balance this. What would you do? You would add something called a coefficient. And coefficients, if you're not familiar, if you forget, coefficients are numbers that occur in front of a value. Let's say, for example, if I put a 2 here, that 2 means everything after my coefficient is doubled. And I want to point out very importantly, you are not allowed to change subscripts. You can't get rid of that number 2. You can't alter the way that certain elements are represented or certain compounds are represented. Certain elements like to exist in pairs. We'll talk about that. And when you're forming a compound, those elements need to bond with each other in fixed proportions. So in other words, that's a very technical way of saying you can't change the subscripts. If I added a coefficient of 2, which I've already done, and if that doubles all of the information afterwards, if I were to go back to my table, I now have 2 sodium atoms and I have 2 chlorine atoms. Back to the gizmo. Let's put a coefficient of 2. Notice that both atoms are doubled. I now have 2 chlorines and 2 sodiums. That's great. Now my chlorine atoms are balanced out, but my sodiums are not. I'm lacking 1 extra sodium. What could you do? Remember, I can't alter my subscripts, but I can add coefficients. So a coefficient of 2 in front of the sodium means that I have 2 sodium atoms. I have 2 chlorine atoms. It appears to me that these are balanced. This is a balanced equation. Let's double check that. Here's a 2. Yes. So 2Na plus Cl2 yields 2 sodium chloride compounds, if you want to think of it like that. All right, pretty straightforward. It's important to stay organized with this table. Let's look at another example. Here's water. We learned that you can separate water through a process called electrolysis, where you take the water compound, you pass electricity through it, and you form hydrogen gas and oxygen gas, 2 elements, correct? So again, remember our first step is to count the atoms to make sure that it is, or to verify if it is balanced or not balanced. Hydrogens. I have 2 hydrogens on the reactant side. Go to the product side. 2 hydrogens. Great. So far we check out. So far we are balanced. Let's look at the oxygen atom. O, I only have 1 O. I only have 1 oxygen here. Product side, look at my subscript. I have a 2. Remember, I can't change the subscript. That needs to stay in place. Let's get a visual for what this looks like. Here's my water molecule, and here is hydrogen, the element hydrogen by itself, the element oxygen by itself. Clearly a mismatch. Something's lacking. Let me start by maybe adding a coefficient. I want to double my oxygens. So let's do that. Let's add the coefficient in front of the molecule. That means that I now have not 1 oxygen, I now have 2. Let's see what that looks like on the visual. Subscript, coefficient of 2, So now I have 2 oxygens on the reactant side, 2 oxygens on the product side. Great, oxygens are balanced. But wait a minute. This changed the quantity of hydrogen. I don't have 2 hydrogens. The coefficient doubles everything that follows. I have 4 hydrogens. There is a mismatch, right? 4 hydrogen atoms do not match with 2 hydrogen atoms. So what could you do? Let's add a coefficient of 2 in front of the hydrogen. It appears that we are balanced. Let's go back. Let's use our table. 2 times 2 is 4. I can now adjust and update 4 hydrogens on the reactant side, 4 on the product side. 2 oxygens on the reactant side, 2 oxygens on the product side. This is balanced. Some of these steps might be a little bit confusing to you. We are not going to go in depth in balancing chemical equations until a little bit later in the year. The only skill, the only task you need to be able to do is to look at a chemical equation, and determine whether it is or it is not balanced. So remember that question I asked you before? There was something wrong with this reaction. See if you notice and see if you can tell if this is a balanced or not a balanced chemical equation.